Welcome to another episode of Knowing the Unknown in Selfie Story Channel. Dive into the core of your being, where the blueprint of life resides, your DNA. This double helix structure, a marvel of nature, is the foundation of all life as we know it. It's as if we're all carrying around a detailed instruction manual in every cell of our bodies, a manual that dictates how we grow, function, and reproduce. Let's take a moment to appreciate the intricacy of DNA. It's composed of two strands, each one a long, linear molecule made up of millions of tiny building blocks called nucleotides. These nucleotides come in four types, represented by the letters A, T, C, and G. The order of these letters determines the instructions written in our DNA, much like how the order of letters can form words, sentences, and ultimately, the chapters of our unique life stories. But the wonder of DNA doesn't stop there. It's not just a static set of instructions. It's a dynamic, living entity, constantly unzipping and rezipping, replicating itself, repairing errors, and even recombining in new ways to create variation in life forms. And yet, for all its DNA is remarkably compact. If unwound and linked together, the DNA in a single human cell would stretch nearly 6 feet. However, it's so finely coiled and packed that it fits into a space just about the width of a hair. Such is the grandeur of this material of life. But here's where things get even more interesting. While it's clear that DNA is essential for life on Earth, could it also be the key to understanding beyond our planet? Consider this. The elements that make up our DNA, like carbon and oxygen, weren't created on Earth. They were forged in the heart of dying stars, scattered across the cosmos in spectacular supernovas, and eventually found their way our planet. So, in a very real sense, we are made of our DNA. The blueprint of life is a testament to our cosmic heritage. Our DNA, a marvel of nature, yet might it hold the key to our celestial origins? As we delve deeper into the mysteries of life and the universe, we might just find that the answers are closer than we think, hidden in the very fabric of our being. Delve deeper into the cosmic narrative etched within our DNA. Our DNA, the complex and intricate blueprint of life, might hold clues to our cosmic origins. One fascinating theory proposed by scientists is that of Panspermia, the idea that life on Earth may have hitched a ride from the distant corners of space. Imagine, if you will, a comet or meteorite hurtling through the vast expanse of the cosmos. Within it, microscopic organisms, or the raw ingredients for life, sheltered from the harsh conditions of space, survive the journey. Upon crashing into Earth, these extraterrestrial travelers could have sowed the seeds of life as we know it. This isn't just a whimsical idea. There's quite a bit of scientific backing to it. Astrobiologists have discovered amino acids, the building blocks of proteins and thus life, in meteorites that have landed on Earth. Even on comets, we've found complex organic molecules, the likes of which are essential for life to form. But the connection goes beyond these life-creating ingredients. The very elements that make up our bodies, the oxygen we breathe, the carbon in our cells, were all created in the furnaces of stars. Every atom in our bodies has once been part of a star that exploded in a supernova, spewing these elements across the universe. We are, in essence, made of star stuff. This idea, popularized by astronomer Carl Sagan, reminds us of our profound cosmic heritage. Our existence is deeply intertwined with the life and death of stars. In the grand cosmic narrative, our DNA might be a testament to our stellar lineage. As we unravel its complex code, we might find more clues pointing to our origins, not just on this blue planet, but in the vast, star-studded cosmos. Could we, beings of Earth, carry the legacy of stars within us? As we continue to explore and understand, we might just find that our connection to the cosmos is not just metaphorical, but molecular, written in the very fabric of our being. Venture beyond Earth, into the vast cosmic ocean where our elements were born. Let's journey to the cradle of our existence, the universe, where the story of every atom in your body begins. Stars, those glittering jewels in the night sky, are not just for making wishes. They are cosmic factories where the magic of element creation happens. Every atom of oxygen you breathe, the iron in your blood, the calcium in your bones, and even the carbon that forms the backbone of your DNA, were all forged in the scorching hearts of stars. But these elements didn't stay locked away in their stellar birthplaces. When stars reach the end of their lives, they don't go quietly. They explode in spectacular supernovae, scattering their enriched guts across the cosmos. These celestial remnants, stardust, wander through space, becoming part of interstellar clouds, the cosmic nurseries where new stars and planets like our own are born. Imagine this. Billions of years ago, one such cloud in our corner of the Milky Way collapsed under its own gravity. As it collapsed, it spun, flattened, and heated up, forming a rotating disk of gas and dust. In the center, our sun ignited, while the outer parts of the disk coalesced into planets, including Earth. As Earth formed, these cosmic ingredients became part of our world, incorporated into the air, the oceans, and the crust. And from these elements, life as we know it emerged. But here's the mind-bending part. Could these elements have brought life itself to Earth? Could our DNA, our very blueprint of life, have originated not on our home planet, but in the farthest reaches of space? It's a tantalizing thought, one that bridges the gap between astronomy and biology, and brings us a step closer to understanding our place in the universe. Our planet, a tiny speck in the cosmos, teems with life made from the ashes of stars. Embark on a journey through the theory of panspermia, a cosmic voyage of life. Panspermia, a concept as intriguing as its name, suggests a fascinating possibility. What if life, as we know it, didn't originate from our beloved Earth? Instead, picture this: life, teeming in a far-off corner of the cosmos, hitching a ride on cosmic dust, meteorites, or comets, and then crash-landing on Earth, kickstarting the evolutionary process that eventually led to us. It's a captivating idea, isn't it? But it's not just a flight of fancy. There's some tangible evidence that lends credibility to this theory. Take, for instance, the discovery of amino acids in meteorites. Amino acids, the building blocks of proteins, are fundamental to life as we understand it. Finding them in meteorites suggests that the ingredients for life could indeed exist beyond our world. But how could life survive the harsh realities of space? Well, some microorganisms on Earth, known as extremophiles, thrive in conditions that would be lethal to most life forms. From the crushing depths of the ocean to the scorching heat of volcanic vents, these hardy creatures prove that life can adapt to an astonishing array of environments. Could it be that similar life forms survived a journey through the cosmos? The potential implications of panspermia are profound. If life can travel between planets, even galaxies, then it becomes a universal phenomenon, not an Earth-exclusive event. It opens up the possibility of life existing elsewhere in the universe, maybe in forms that we can't even begin to imagine. But let's not get ahead of ourselves. While the evidence supporting panspermia is compelling, it's not yet definitive. Continued exploration of our universe, both near and far, is needed to unravel this cosmic mystery. Regardless of the outcome, the quest to understand our origins pushes the boundaries of our knowledge and ignites our collective curiosity. Life, it seems, may not be confined to our blue planet, but may be a cosmic wanderer. Are we, in fact, the aliens we've been searching for? A question that pulls us deep into the heart of our own identity. If panspermia is true, if the seeds of life did not originate from our own planet, but rather hitched a ride on a comet or meteor, then perhaps we are more extraterrestrial than we ever imagined. This theory, while not yet proven, forces us to rethink our place in the universe. We are not simply inhabitants of Earth, but rather we are made of the same stuff as the stars. Our DNA, that intricate blueprint of life, may have its roots not in the soil of our planet, but in the far reaches of space. The implications of this idea are both philosophical and scientific. On one hand, it broadens our perspective of what it means to be human. We are more than just terrestrial beings. We are cosmic citizens, part of a universe that is far more interconnected than we ever realized. On a scientific level, the theory of panspermia challenges us to redefine our understanding of life. It suggests that life is not unique to Earth, but rather a cosmic phenomenon. It opens up the possibility of life existing elsewhere in the universe, perhaps even in our own solar system. Furthermore, if we are indeed extraterrestrial in origin, what does this mean for our search for alien life? Does it broaden our definition of what we consider as alien? If life on Earth originated in space, then perhaps our search for extraterrestrial life is not a search for the other, but a search for our own cosmic cousins. It's a humbling thought, isn't it, that we are not the center of the universe, but rather we are a part of it. We are not separate from the cosmos, but intricately woven into its fabric. We are the children of the cosmos, our bodies stardust, our origins possibly not of this world. We are, in the grandest sense, citizens of the universe.